Hello everyone. In this video, I will do an example for critical numbers. And the example goes find all critical numbers of the function f of x equals to 4x plus 1 over x minus 1. Okay, so let's just first recall what does critical numbers. If if the function f is defined at C and f prime does not exist oh, at C, or it exists but the derivative at that point is 0. That's the definition of this guy, what the critical numbers are. So here what we need to find f prime, and this is 4x plus 1 derivative of numerator times the denominator minus the numerator times the derivative of the denominator and denominator squared. This gives me 4 times x minus 1 minus 4x plus 1 times 1. The derivative of x minus 1 is just 1. And from there, you see that I have 4x minus 4 minus 4 minus 4x minus 4x minus 1 over x minus 1 squared. This cancels with that, and f prime of x is negative 5 over x minus 1 squared. This is a nice thing. So now we have f prime. We have to check first, is there any point? Is there any C at which f prime is not defined? That's the first type, and then we will do check if is there C at which f prime vanishes, or f prime of that point is 0. Okay, so let's see here. I have in the denominator I have x minus 1 squared, and it can be 0 actually when x is 1. So at x equal to 1, f prime is not defined. Wait a minute. You have to be very careful. You have to first make sure that f itself is defined at C. Then look for a point at which f prime is not defined. But here, note that f itself is not defined at x equal to 1. So x equal to 1 does not satisfy this condition that f needs to be defined at C. So this is not a critical point. How about f prime being 0? F prime of x being 0 means what? Means that negative 5 x minus 1 equals to 0. That means that negative 5 needs to be 0. Negative 5 never is equal to 0. So that means that f prime is non-zero everywhere. So what does that tell us? It means that f has no critical number.